Good evening. So tonight I'm going to talk to you about the future of intelligent fabrication. But first of all, let me ask you a question. What do you think of when you think about fabrication? Is it this? Yes? Yes? Is it this? Could be. How about this? Yes, they're all examples of fabrication. They're all examples of welding being used in practice to fabricate components and structures. Let's just take those pictures again, and this time we'll look at them from a complexity point of view. So back to the first one. Here, the welder may or may not have a high degree of skill. Now, I happen to know who this is, and they do have a high degree of skill. They work with me. But the component they're making is not really all that complicated. So it's welding being used to make something that's not really all that complex. In the second scenario, what we're seeing here is, as you will recognize, it's an automated production line for car manufacture. And it's a pretty sophisticated setup. It's a very expensive setup. You can see all of those yellow robots going mad on that car. But actually, the complexity is not that great, because what each individual robot is being confronted with is a very highly toleranced piece of steel coming towards it, or metal coming towards it, and all it has to do is simple spot welds over and over again as those items come past. So the complexity at the level of the individual weld is not that great. This one, on the other hand, you go and say somebody's welding up a pipe in the middle of Australia. That doesn't look too hard. But actually, this is a high-pressure gas transmission pipeline. It's critical infrastructure for the delivery of energy around our country. Safety requirements, integrity requirements on this are extremely high. The steels being used are very sophisticated. These productions are made at very fast rates, and so this welder has to be extremely skilled to hit those levels of integrity and quality, but meanwhile keeping everything going at a very fast rate. So actually, this is a very complex thing that's happening in a very challenging environment as well. This could be 45 degrees wherever these people are. So this is a very complex use of welding technology. And I'm particularly excited about this one because this is my own personal area of expertise and interest. So let's have a little history lesson now. First of all, let's think about welding. Now, welding, as we sort of know it, was first sort of dreamed up in the early 1800s. But arc welding, as we use nowadays, really had its genesis at the beginning of the 1900s. 2 world wars really helped move that technology along, as it is with much of technology in our world. And nowadays we have a wide range of welding processes that we can use to join a wide range of materials. Fabrication has also come a long way from the Industrial Revolution through to mass production, automation, and customization. And over the last 100 years, we've really gone from, for example, the Model T Fords, where you could have anything you wanted as long as it was black, i.e. really you had no choice at all, to nowadays, where, if I'm allowed to misquote McDonald's, you can have it your way. So here in Australia, we have quite a large manufacturing and fabrication industry sector. It's a sector that helps drive economic growth in our country. It creates and sustains jobs, and it helps us adopt technology into what we do. It gives us that opportunity to embrace innovation. But Australia has its own set of challenges in this space as well. We've got a relatively small population spread out over a very large area. We've got a very distributed population. We have a disproportionate number of small and medium-sized companies in this country. In fact, only 1.6% of all companies employ more than 200 people. So we're really short of that big scale that we see in other countries. Thirdly, we're up against increased competition from overseas companies, both in our domestic markets and in our offshore markets. And finally, the labour costs in Australia are relatively high compared to other countries that we're competing against. But thankfully, trends in manufacturing are moving in a direction that sets up an environment that gives Australia the opportunity to become more competitive. And those trends are things like the move to making one-offs, to making bespoke production, and customer-driven products. And that level of customisation and specialisation allows Australians to play to their strengths in those areas to gain that competitive advantage in an economic and efficient manner. And we can do this by applying our intelligence and our innovation to those challenges in a way that gives us that competitive advantage without having to fall back on the traditional volumes and economies of scale that people have relied upon on the past for competitive advantage. So now I've kind of set the scene for you a little bit. Let me talk a little bit about what we're doing here at the University of Wollongong within the Facility for Intelligent Fabrication. In that team, we've got a group of people who are experts in welding, in automation, and in fabrication, and in robots. And what that group are doing are bringing those skills together to provide solutions for industry that are responsive, they're tailor-made, and they're readily implementable. And so we can really help the companies that we engage with change what they're doing and really get themselves up the curve in those areas. We do use robots in what we're doing, and those robots help us provide flexible solutions so that we can really deal with those low volumes that I've been talking about and deal with them in an efficient and very economic kind of way. Now, I'm going to move to a video and show you a video about some of these things, but I just want to sort of address what you might think about robots. Normally, we think about robots as things that people program. They sit down and they spend hours, days, weeks, months programming a robot. And for a very complex operation, the amount of programming that goes into those robots is really quite high. What we're doing here at the University of Wollongong is something completely different, where the robots are driven by software that can learn for itself and it can figure out what to do, and you don't need all of that intensive programming up front. Now, it's very easy to start to think about the robots as things that are thinking and living almost. They're so smart in the way that their software gets used. But let's have a look at the videos. So in this first robot, this is the robot's laboratory here at the university, and if I got my orientation right, it's sort of over there. And what this robot is doing, it's doing standard kind of pick and place type work. So this robot knows, it's been programmed to deposit these panels in specific locations. Now, normally if a person was doing this, or a standard robot, it would place the components and jig them and then weld them. But here we're doing it all at once. And so when you put this final component on, it fits on snugly. There's no pushing and shoving to try and make it all work and fit together. And it's done all that in the time it's taken me to explain it. And now what would happen was that the robot could then go on and weld up that component fully, or we could move on to another station. This could be integrated with a robotic laser cutter that could then deliver those products to this, so we could fully integrate this. So this is the first level of sophistication I want to show you. In the second level of sophistication, we take a computer diagram, a CAD drawing, and we import that into the computer, into the software. And so now the robot, if you like, if you can think of it like this, knows what's going to be in front of it. We could put the robot into the simulation here. It runs through the simulation. It works out where in those components it's going to need welds, where it should put welds in what order, and it's just running through. And now we move to the real thing. And so if you look to the left of the screen, there's a solid steel base plate and a vertical steel plate as well. These are going to be welded together. And so in the time, again, that it's taken me to explain it, the software is clicked through. The robot is just sensing the starting position and the finishing position of this particular weld that it's going to do. You see it's gone straight to where it needs to weld, back to the beginning, and off it goes. Now, in the video, we're not actually welding because we would blind you with just light, so this way you can see what's actually happening. So it's a very efficient conversion from a CAD drawing being imported into the software through to making the weld. Now, in this third video, this is the next level of technology up. The computer has not been given any information whatsoever about what's on the table in front of it, but it's used a light scanner to build up an image. And so we're going to look at the one again on the left-hand side. Everything that comes up yellow or red is fixtures and jigging, and it knows that that's not part of the component. So again, in the time it's taken me to explain it, the software's gone through. The robot's off, it's making the weld, it's taking the most efficient path across the bottom, now it's going from the top, it comes down. You can see that it's kind of adapting, twisting to get the right angles. It's not going to interfere with any of the jigging, and then continues on welding. So what you're seeing there is 3 levels of sophisticated technology, programming of that robot, that we don't have to spend all that time really endlessly programming it for one application. What we can do here is provide the robot with the software with information or not about what's in front of it. And the robot software can take that, work it through, and work out exactly what it has to do to make the finished product given what it has in front of it. Now, that's very sophisticated technology. Now, for the sake of the video, the components on the table were very simple. Otherwise, you kind of get distracted by the complexity of what's there. In real life and in the applications we work on with industry, the geometry of what's in front of the robot can be extremely complex to the point where it would actually be very difficult for a human to actually weld it up. We need to use robots. And the materials that are being used are very complex too, difficult to weld materials. So this is where this technology really comes into its own with those complex geometries and those difficult to weld materials. So if I can bring you back to the beginning of my talk, if you remember we started talking about welding, we talked about complexity. What I've just shown you in the video is really at the advanced end of this spectrum of both the welding technology and of the complexity. And so this is what we're doing within the facility for intelligent fabrication, where that group of people are really delivering those flexible solutions for industry. And I hope in my talk today I've managed to give you a bit of an oversight of what we do, what we can do today. And really, as we move to the future, just imagine if. Thank you.